So hi everyone, it's me again, Kit Alon Human, BSMA second year. So for today's video, we're gonna task to explain and answer the problem. So by the using of the circuit laws and theorems, which is the KCL, which means Kirchhoff's current law, and also the KVL, which means the Kirchhoff's voltage law. So KVL means that states that the sum of all voltage in a closed path is equal to zero, and also the KCL or the current so states that all current that connects in a joint has a or equal to. So the question is how much current is delivered by each battery. As you can see in our diagram, the circuit diagram, so we have the EA and AB, which has a 24 volts each, and we have the loop TSRPON and has a resistance of 0.2 for the RA, and for RB is 0.2 ohm, and for the load which has a 2 ohm. So for solving this problem, so we are tasked to solve this problem using the counterclockwise direction. So as you can see, we draw the arrow for counterclockwise. So first, we need to apply the KCL. So KCL means the Kirchhoff's current law. So let's first identify the current. So applying KCL at junction O or node O. So here, so at the center, so the junction. So as you can see in the diagram, so we have the IE, IB, and IL. So as you can see, so IE is entering to the junction O. So it means that it is a positive. So IE. And of course, the IB is entering also in the junction O. So it is also a positive. So IB. Since IL is leaving or releasing the current, so downward, so it is a negative. So IL is equal to 0. So therefore we have an equation for the KCL, IE plus IB minus IL is equal to 0. So let's say it is a equation 1. So this is the first equation. So next, by applying the KVL so we need to apply the KVL for the loop outside. So KVL is the Kirchhoff's voltage law. So at a loop, so we are tasked to solve in a counterclockwise. So we will start for the T, and then S, R, P, O, N. So at the loop, T, S, R, P, O, and T. So we will gonna start here for EA. So AE is entering to counterclockwise. So as you can see, the IE is entering to the junction O, while the EA is opposite from the IA. So it becomes a since it entering to negative, so it is a negative EE, and then the loop will direction travel to EB. So hence AB is same direction for the IA. It has a positive, so plus AB, and then it enters to the RB, which multiplied by the IB. Since it has a same direction, so that and same direction and has a negative, so negative IB multiplied by RB. So next is the IE in RE. So as you can see, has a opposite direction. So therefore, negative oh, oh, I positive rather, since it is opposite. So positive IE RE is equal to 0. So is equal to 0. So this time we need to plug in each value. So IE is 24, so negative 24 volts plus the 24 volts for AB. We have a, since we only have a RB, so we can plug in the 4.2 IB, plus we have also the RE 0.2 multiplied by the IE is equal to 0. So since, as you can see, we can cancel out for the negative and the positive 200 volts. So the only have is negative 0.4 IB plus 2.2 IA is equal to 0. So this is the equation of equation 2, which means we form the second equation. So equation 2. So we can also have to divide both sides by negative in order to become a positive, but for this time I did not change their sign. So next we also applying the KVL for this loop from TSON. So counterclockwise direction. So we'll start for TS. So at loop TSONT. So we can have to create for another equation. So the direction is travel along this from AA. So AA is negative, and then travel to RL, which multiplied by IL. So it is positive since it is opposite. So multiplied by IL RL, and then it travels to RE and IE. Since it is opposite also, so it is counterclockwise. So this is a positive. So plus IA RA is equal to 0. So we can plug in their values. So negative 24 volts plus we have the 0.2 IL plus which the value for RL, which is 2 multiplied by the IL is equal to 0. So this is a question 3. So as you can notice that they have the common, which is the IE. So as you can see for this equation, so we have the 0.2 IE. For equation 3, we have the also in equation 2, which is 0.22 IE. And also for our first equations, we have IE. So next step to do is for our elimination. So how we are going to eliminate for this problem. So by eliminating, we can use for the equation 1 and equation 2 for eliminating. Eliminating IA. So equation 1, we have the IA plus IB minus IL is equal to 0. And for the equation number 2, we have a negative 0.IB plus the 0.2 IA is equal to 0. So so for this step, no, so as you can see, IE plus IB. So how we are going to cancel out for the IB? So we need to eliminate this IB to get the IE. Eliminate B, get IE. So we need to multiply the value for the first equation, which is 0.4. So let's plug in the value. So 0.4 IA plus 0.4 IB minus 0.4 IL is equal to 0, and then here it is. So we can cancel out for the value of IB. It's because it is opposite sign, so negative and positive. So cancel this. So we can add this equation. So for negative, so negative 0.4 IL is equal to 0. So this is 4 rather. So when we multiply 0.4 multiplied by 5, we can get 2. So we can cancel it out. So it is a negative sign. So IE, so negative 2 IL is equal to 0. So since when we multiply 0 to 5, it is a 0. So we can cancel out these two equations since we have the same value for IL. So it is we can cancel this value since it is an opposite sign. So next we can add these two equation. So same value for IE, we can add 0.2 adding with the 3 IA, so we can have a 3.2 IA and is equal to 24 volts. So we can divide both sides by 3.2 to cancel out the value for IA, and IE is equal to, so 24 volts divided by 3.2, so we can have the value of 7.5 amperes. So since we have already IE value, so we can find the next value for the IE. So we can find the value for IL using the equation 4. So equation number 4. So we do rewrite the equation for number 4 to make it clear. So 0.6 IA minus 0.4 IL is equal to 0. So we do have a IE for 0. Which has is it value of 7.5 ampere. So we can plug in the value of IE. So 7.5 minus the 0.4 IL is equal to 0. So 0.6 multiplied by 7.5 and 4.5 minus the 0.4 IL 0. So we can transpose this IL since it is negative. We can transpose here. So the value is 4.5 is equal to 0.4 IL. So we can to cancel out the 0.4, we need to divide both sides by 0.4 value. So cancel this one. So IL is equal to 4.5, which divide by 0.4. So using the calculator, so we do have the value for which has a value 11.25 amperes. Since we will do have the IE and the IL, so the last one that we need to find is for the IB. So with the using for the equation 1, this equation, so IE plus IB minus IL equals 0. So IE plus IB minus IL is equal to 0. So we have the IL 11.25 and we have the IE is 7.5 ampere. So we need to plug in the value for IE is 7.5 ampere plus the IB, so plus IB and minus the 11.25 is equal to 0. So say 7.5 minus 11.25, so we can get so negative 3.75 plus the IB is equal to 0. So therefore we can transpose the negative 3.75 to this side for us to become a negative. So IB is equal to 3.75 ampere. So we already get the three values for every current of the batteries delivered by the batteries. So in summary, the IE has a value of 0.75 ampere. IL has a 11.25 ampere, and the last one is the IB, which has a 3.75 ampere. So in addition for this explanation, so to get an easy value, or we can use the scientific calculator. So in using the scientific calculator, we can plug in the three equation, which is the IE plus IB, IL equals 0, and this one. So we can transpose to 0.2 IE plus 2 IL is equal to 0, and the last equation, which is the 0.6 IE, this is a negative sign. 0.4, this is 4, IL is equal to 0. So when you plug in into the scientific calculator, we can get the same answer. So that's all for the explanation, and thank you.